Choosing a blockchain in 2026 is not about chasing the loudest ecosystem. It is about matching a business problem to governance, privacy, interoperability, and maturity. In this course, we will build a practical framework for making that choice defensibly. Blockchain's role in 2026 is less about hype and more about trust infrastructure. The strongest use cases involve many parties, shared records, and assets that need proof. Tokenization is moving into regulated production. Stablecoins are changing settlement. Verifiable credentials are making identity more portable. Supply chain and compliance still benefit from tamper-resistant records. The strategic question has matured from, should we use blockchain? To what trust architecture does this ecosystem actually need? A strong blockchain strategy starts with restraint. If one trusted organization owns the data, controls the process, and can enforce the rules, a normal database or workflow system is usually better. The same is true when speed is the main requirement, or when shared auditability, provenance, and independent verification do not matter. Blockchain becomes useful when multiple parties need a common record they can trust, without handing control to just one participant. The enterprise blockchain landscape is best understood as a set of operating models, not a race between brand names. Public chains maximize openness and verification. Layer 2s add speed and lower cost while inheriting public ecosystem security. Permission chains prioritize control and known participants. Consortium networks distribute governance across organizations. Hybrid designs keep sensitive workflows private while using public proofs where trust matters. Start with governance, risk, and integration needs, then choose the platform. Blockchain models are different trust designs. Public networks maximize openness. Anyone can participate, verify activity, and benefit from broad ecosystem liquidity. Private networks narrow participation, giving one organization stronger control, privacy, and compliance management. Consortium networks sit between them, with several known institutions sharing governance and validation. None is automatically more enterprise-ready. The right choice depends on who must trust whom and how much control they need. The next question is, who needs permission to do what? In a permissionless network, anyone can join, transact, validate, or help govern if they follow the protocol. That creates openness and censorship resistance. In a permission network, identities, roles, and access are managed by policy, which supports privacy, compliance, and control. This is not exactly the same as public versus private, and many enterprise designs combine both. Use blockchain only when the architecture needs shared trust. If one organization controls the data, a normal database is usually enough. If several organizations interact but do not need one shared truth, APIs or integrations may solve the problem. Blockchain starts to make sense when multiple parties need the same record, trust is limited, audit history matters, and independent verification adds value. Otherwise, simpler architecture is usually the better choice. Public blockchains make sense when openness is not a drawback, but the source of value. If users, regulators, or markets need to verify activity independently, a public network can help. The same is true when you issue tokenized assets, connect to wallets and stablecoins, or need access to DeFi, NFTs, exchanges, and consumer applications. The trade-off is design complexity around transparency, variable fees, compliance, and data privacy. Ethereum is often the default benchmark for public smart contract networks because its ecosystem is so complete. Developers have mature tools, wallets, auditors, standards, and libraries. Institutions recognize ERC token patterns, and liquidity is deep across stablecoins, NFTs, tokenized assets, and dApps. That does not make Ethereum the best answer for every use case. High costs and scale requirements often push activity to layer 2s. But as a reference point for tokenization, it remains hard to ignore. For many enterprise use cases, Ethereum mainnet is too expensive and capacity constrained for every transaction. Layer 2s, including Polygon, move high-volume activity to cheaper, faster networks while still connecting back to Ethereum's ecosystem. That makes them practical for loyalty points, tickets, gaming assets, consumer NFTs, and token operations. They are not universal replacements, though. Evaluate the security model, developer ecosystem, and operational maturity before choosing one. High-performance public chains are attractive when the application experience depends on speed. Solana is often considered for consumer apps, payments, and trading-style flows. Avalanche stands out for configurable subnets and institutional experimentation. Aptos emphasizes a modern stack, scalability, and developer experience. The trade-off is maturity. Before choosing performance over broader network adoption, evaluate ecosystem depth, uptime, custody, tooling, and compliance. Public chains should be treated as a shortlist, not a leaderboard. Ethereum is the safest default when ecosystem depth, standards, and liquidity matter most. Polygon and other Layer 2s keep Ethereum compatibility while reducing cost. Solana prioritizes speed and consumer scale experiences. Avalanche is useful when configurable networks and institutional patterns matter. Aptos is earlier, but interesting for high-performance architectures. The right choice depends on the requirements. Private and consortium blockchains fit a different pattern. Several organizations need a shared source of truth, but they cannot expose everything to everyone. The participants are known, access is permissioned, and governance is agreed up front. This is common in banking, supply chains, healthcare, and regulated industries. The value is not radical openness. It is coordinated operations, auditability, selective disclosure, and trust between institutions that still need boundaries. Hyperledger Fabric is built for business networks where participants are known, but their data still needs boundaries. Instead of one public ledger where everything is visible to everyone, Fabric uses membership, channels, and private data to control who can join and who can see what. Its modular design lets organizations choose identity, consensus, and governance patterns that match policy. That makes it useful for supply chains, healthcare, government, trade finance, and other shared operational workflows. Hyperledger Besu is useful when an organization wants Ethereum tooling along with enterprise controls. Because it is EVM compatible, teams can reuse Solidity skills, smart contracts, and token standards. At the same time, Besu can run permission networks with governance, privacy, and compliance requirements. That makes it a practical choice for tokenization, CBDC pilots, and regulated digital assets that may later connect to broader Ethereum ecosystems. Corda takes a different approach from public blockchains. It is built for known organizations that need shared, legally meaningful agreements, especially in finance. Instead of broadcasting every transaction to everyone, Corda shares data only with the parties who need it. That makes it useful for banking, insurance, capital markets, and trade workflows. Beyond the main platforms, you may encounter niche or legacy options in evaluations. Quorum matters mostly through its Ethereum enterprise lineage and consensus ties. Indy and Aries are strongest for decentralized identity. Canton is built around institutional finance and regulated asset synchronization. Iroha fits simpler permissioned asset or identity needs. For Sawtooth, multi-chain, or inactive projects, check maintenance, community health, and roadmap before committing. Use case mapping is a starting point, not a shortcut. Supply chain may lean toward Fabric when private channels matter, or Besu when token logic matters. Banking can point to Corda, Besu, or Canton depending on how parties form agreements. Tokenized assets and identity depend heavily on verification, liquidity, and interoperability. For carbon credits, real estate, loyalty, and real-world assets, choose governance first, then match the platform to the workflow. Platform choice should start with requirements, not brand preference. If you need public verification or liquidity, Ethereum and Layer 2s are natural candidates. If privacy, access control, and known participants dominate, look at Fabric or Besu. For Ethereum compatibility inside an enterprise perimeter, Besu is often strong. For financial agreements, evaluate Corda, Canton, or Besus. For credentials, consider Indy, Aries, Ethereum, or Besus. Score the fit against the actual workflow. The takeaway is simple. There is no universal best blockchain. Match the platform to the problem. Use public ecosystems for openness, Layer 2s for cost, high-speed chains for scale, and permission networks for control. Decide governance early, then design for privacy, integration, and interoperability.